CubeSat mission definition and design and live discussion. Please note that this session will be recorded and it will be available on our website in the media gallery afterwards. We'd like to remind all participants to please turn off their mics and mute their mics if you're not part of the discussion today. And with that, I'm going to introduce Mr. Luis Santos, who is going to be moderating today's session. Luis has a BS in mechanical engineering from the University of Puerto Rico, Maiguez, and a master's degree in systems engineering from Old Dominion University. He started his career as a mechanical design engineer for Composite Crew Module, Altair Lunar Lander, and Global Participation Measurement Mission. He has over 10 years of CubeSat smallsat experience, including 4 smallsat technology patents and several CubeSats as the mission systems engineer. And with that, I will go ahead and hand over to Luis, and we can begin the presentation.
On the proposal and early stages of a project. Tomorrow at the same time as today. I will start the conversation by asking questions to our panel. If you will at any moment, please use the raise hand feature within WebEx, or and I'll call your name to participate. You could also post your question on the chat functionality if you prefer. Now, I would like to introduce our panel for the discussion today. First, we have Dr. Sean Semper. So Dr. Semper is our product development lead and mission systems engineer for BurstCube and PetitSat. His background is in mechanical and aerospace engineering at the GNC hardware branch. Welcome, Sean.
Hey, how's it going?
Good. We have small site portfolio manager providing NASA mission science, the science portfolio. John has also been involved in small sat technologies and mission developments. His background is in design of satellites. Welcome, John. Are you still there, John?
Thanks, Luis. How's it going?
Okay. Next, we have Juan Raymond. Juan is our mission systems engineer for the Dione mission. Juan has worked as a systems engineer for multiple missions, and his background is primarily in guidance, navigation, and control, and attitude determination and control systems. Welcome, Juan.
Thank you, Luis.
Next, we have Ben Cervantes. Ben is our mission planning lab lead at Wallace Flight Facility. He has led over 30 mission concept studies, many of them leading to selected proposals. His background is in software simulations and visualization for mission real-time operations. Welcome, Ben.
Good afternoon, everybody.
And then finally, we have Will Mast. Will is our mission systems engineer for the Science Enable for Heliophysics, or SEF mission. Will also serves as the systems engineer behind the mission plan system. His background is mechanical engineering and systems engineering on multiple platforms, including sounding rockets and balloons. Welcome, Will.
Thank you, Luis. Good afternoon.
All right, so let me kick off the discussion with a simple question. What is the mission design lab at Greenbelt and the mission planning lab at Wallops? And maybe Ben, you can start the conversation on that.
Yeah, thank you. So the mission planning lab at Wallops, lots of other people have these kinds of labs, and what it is it's a kind of concurrent, multidisciplinary engineering lab space where a PI or a principal investigator will come in, and they'll have pre-work forms to fill out, and then we work through a mission feasibility concept study with all the different roles required for that particular study. So we have lead systems, mechanical thermal, GNC, power, comm, CNDH, other roles as necessary. So if it's like the interplanetary, we bring in propulsion, subject matter expert, flight dynamics, radiation type folks. And so what occurs is we look at their concept over the course of a week and try to get that point design to close, and try to some more. We're primarily doing spacecraft bus design, feasibility of the concepts, and potentially a little instrument work. We've also done some work with the scientific balloon like platform as well. And then the mission design lab, perhaps some other folks can speak to it more about it, but it operates very similarly. They've been around much longer. Primarily, the facility itself is hosted at Greenbelt, within the Goddard campus, Greenbelt campus. And they've been operating for a number of years into the early 2000s, if not like 1999 or so, and have between them and the instrument lab have well over like 400 studies that they've done. And these are for larger satellites, different kinds of mission classifications, but it's my understanding they've done some small sat design work as well. The mission planning lab is on mission small sat, ESPA size concepts.
All right. So in your experience, and John and Will, who's been through the process as well, what do you recommend? What kind of homework a PI can do before going into the mission planning lab to get the most out of it? And you don't want to do it too early. You don't want to do it too late in the proposal process. So what is the sweet spot for an MPL session?
Was that to me directly, Luis? I'm sorry, was that to
Yeah, that
Will
would be
or-
to you, Will, and John. So Will and John, maybe if you want to.
I can speak a little bit first and then pass it over to Will. So on the pre-work side, it's definitely beneficial depending on the proposal class, like to do it a little earlier. But the PI has to understand what their mission concept is, what their requirements are, such that they can get enough out. Have the instrument design kind of fleshed out so that we can package it and understand the trades and understand what kind of power that system needs, what are mechanical interfaces, what are pointing requirements, those types of things. And so if they have that information, they can get a good head start with doing a mission planning lab study, but you don't want to obviously wait till the last minute before a proposal, because then it's too much work to squeeze in before the due date. Perhaps Will serves in the mission planning lab, and John has in the past too, and Will's been systems engineer in there and sits in on a little sections. Maybe he can elaborate on what that looks like.
Will and John.
Yeah, I mean, all I can do is kind of just go on what Ben said in terms of having your instrument ready. We spend a lot of time churning on instruments. You don't have them ready, so you waste a lot of time. Most of the design happens over the course of 3 days, so you got to spend a day and a half trying to redesign or design an instrument. You're really going to miss out and diving deep into your mission concept. One of the main benefits is really understanding where your concept's going and what the challenges are, so you can learn where you need to invest in your concept coming out of the mission planning lab. So,
All right. Will, do you want to? Are you good? I think you're muted, Will, but let's.
I'm sorry, I have been muted. Yeah, I think the pre-work in a lot of ways more important than the study. It's important to get the science team focused on their science objectives and understand what they want to accomplish. It's usual for a team to and have a project that revolves around a certain platform, a specific CubeSat, and they've usually got an operations already established. But with a good pre-work session, we can find out, if what they're coming in with is really suited and if it really meets their objectives. Also, we use the deep bench at Goddard.
Oh my God.
Having some technical difficulties. Apologize about.
Difference between successfully defining a mission at the end of the week and basically spinning, yeah, not being able to converge on a that's also Heinz project, Heinz team.
All right. Thank you, Will. So, in your experience, Juan, Sean, and everyone else, what are the challenges that you have run into during the proposal development? And specifically, if you have experience on a specific mission class, like the 7120.8 research and development versus Class D type small sats.
Well, I can speak to it, but my most recent proposal was a Class B mission. So I don't know if it applies completely to Class D or below missions, but I think the process is the same and everybody faces the same challenges. So when you're cost cap and you have little time to put together a proposal, you pick a baseline that is not fully vetted for the mission you're planning to design or the intent. So the challenges that follow that study, I mean, we sit in the MDL, we pick a baseline architecture, and we assess the risk or the suitability of or feasibility of that design for the mission intent. Then when you get to the actual proposal, you have to really look at it in the in the mission that you're going to try to do, and that is the challenge, because initially your cost cap, you want to fit something that meets the cost within a schedule and with technology that is available. Later you can find the little tweaks, and you spend a lot of time trying to figure out if the technology that you pick is really appropriate for the environment or the place, or it meets the objectives of the mission you're trying to design. So that is the challenge. That's always the gap that you go saying, okay, this is what I can find right now under this cost, but what follows before the selection, it is if it is really adequate for that mission, if the design is the proper solution, and it has gone through all the different heritage or testing or technology readiness level appropriate for the mission. And that's always the challenge on the proposal stage.
Do you have similar experiences, John, and the challenges during the proposal process?
Yeah, absolutely. The proposal process is full of challenges, especially the staffing it. Number one is a challenge. A lot of people are busy, and no one's 100% focused usually on it, and so it's very hard to keep good talent to staff a proposal, especially when it could be a 6-month process to develop one for like a 0.5 mission. 0.8 maybe is like a 3-month type time frame. It's a little bit easier to do that. Yeah, but you have the staff to do the technical challenges, to get through those fine details that Juan was talking about. Is really hard to do in a short period of time with limited staff.
All right. Anyone else want to chime in on proposal challenges?
This is Sean here.
Hey, Sean.
One of the things I noticed, I did a run not too long ago, and it's so challenging. It's good enough because sometimes you're trying to make sure you have enough margin on certain things you're trying to design because it's so early on. But at some point in time, you have to understand that, you know, if you're going to meet the requirements with the hardware suite you have, then that's good enough for the proposal stage. And the other thing is sometimes understanding the ConOps and requirements early on, because those things are a little bit fuzzy and ideas are still being generated in real time. And like was mentioned before, in some cases it's 3 days, in others it's 5, and it feels like you're locked away trying to design something as quickly as possible. So those are a few of the challenges I've noticed.
Yep, that's great. I want to remind the audience, this is a conversation and you're part of it. If you have any questions or anything you would like to talk or discuss with our panel, feel free to raise your hand or write your question on the chat, and we can get it running that way. So so you do your proposal, it goes through the process, and you win your proposal. What is the first thing that you look at or you do from the project management or the systems engineering perspective? And I guess we can start with Will, maybe, like Ice Cube.
Sure. When you actually win the proposal and you start off, you're often the proposal writing team is not the team who actually builds and develops the spacecraft. It's nice if it is, because then you're already up and running. So you kind of have to redo or go through the proposal from beginning to end and review all of the decisions and the designs and make sure that they're still feasible. You staff up your team, you try to figure out realistically how much manpower you're going to need. And most importantly, you get your systems engineering fundamentals defined. You've got to have your level 1 requirements very well defined. You've got to know your margins requirements, and you've got to know your science objectives and your ConOps and how everything comes together. Something that sometimes doesn't get enough attention, but just knowing and agreeing on how you're going to do configuration management is something that can really affect the project positively or negatively right off the bat. Fortunately, we've got some pretty good tools available to us at Goddard. We've got an internal TDMS system, which is good for storing documents, but things like requirements can be managed really well with something as simple as an Excel spreadsheet. The important part is making sure that it's protected and that the integrity of the documents and the integrity of all your basic systems engineering information is protected, so that people, well-meaning engineers, can't come in and change things, and that you have one source of truth for the project to look at.
Yep, good. We have a question on the chat, and I'll leave it open to any of the panel members that wants to tackle it. The question is, what's the progress like on the standardization of CubeSat designs? For example, for the U design, where the structure has been mostly modified, but how about other subsystems like EPS or onboard computers? And I guess how that helps on the mission formulation phase.
I don't want to dominate. I can take a stab at it.
Sure.
I mean, being that we're NASA, we tend to do science missions, and often they don't apply to the normal standards. If it's a standard CubeSat, then it'll typically be farmed out or be a commercial supplier. So it's kind of exciting working in the mission planning lab, because a lot of the things that we come up with, either for thermal reasons or apertures, or there'll be some physical constraint that makes us look a little bit outside of the box. Frequently we have to push the standards, maybe is a way to put it. You try to adhere to the standards as best as to the largest extent that you can, and you try to make it cost effective. But one thing that's exciting is being able to be on the edge of the state of the art.
Yeah, and you know, that's a good question too, because early in the CubeSat process, you know, I saw a lot of that trying to standardize interfaces, and you know, with the CubeSat kit bus and stuff like that, and the different companies trying to do and conform to the CubeSat kit bus, but it's not. Each vendor kind of went their own route on how they wanted to develop their products, and early on we had, you know, individual companies offering individual subsystems. Now the market is going more towards offering a full bus, so it's fully standard for that company. But how one company does the bus is could be very different from how another company does the bus. So you can still buy components from them, but they don't comply with a specific interface or format from the market. It's more geared towards their own product lines. We have another question here. So when some areas has a development delay, what is your approach? Delay the whole project or discuss the mission that can live without the features? So I guess this is a little bit more applicable to tomorrow's discussion on the you know, development, integration, testing with the issues, but you can still have delays and issues early on, especially trying to find your item components and trying to order them as soon as possible. And so what do you do when you get those changes?
Right, maybe I can speak a little bit about recent experience with COVID-19 impact. I guess
Yeah.
That one, and CubeSats don't have the luxury. So if he were, so this is the advantage of CubeSats. We can take the risk and modify our plans. We can do less testing on EM, do more FM flight unit build early on, do more testing in the flight unit. So we can modify plans and tweaks. So that's the luxury of CubeSats, that we can change and we can stay within a schedule and cost, or we can attempt to stay within a schedule and cost. In a large mission, every day that they sleep costs a lot of money. So they don't have the leeway of, oh, well, we didn't do engineering model testing. Well, that is big, because they won't let you go into the flight unit build fabrication until you're done with AM testing and you have mitigated all possible risk with the flight unit implementation. So that's one of the advantages of CubeSat. The challenge is you have to understand what is the risk you're facing by changing the plan, and that's always the trick. So you can live with a little bit more risk, but you can change the plan, accommodate, assess the risk, move with a different plan with an acceptable risk, rather than canceling, because a day-to-day it costs. So we evaluated delaying the project 3 months. That was significant cost that the project was not willing to or didn't have the money to pay. So delaying may mean you will run out of money and you may not get anything done. So it has to be a feature that you have to be able to live with.
Yeah, and John, I think you had an experience on a CubeSat in which you had to not do your mechanical analysis like you typically do, right? So that's another type of consideration that you would make. You want to talk a little bit about that?
Yeah, sure. I mean, sometimes you want to do all the analysis you can, but sometimes you just have to go right to test, for example, and take the risk. And like Juan was saying, on a CubeSat, you have leverage to be able to do stuff like that. Still nerve-wracking as a mechanical engineer to watch on the table without doing your analysis first. But you know, the it costs money, and so you got to accept it.
Yeah, and sometimes use your engineering judgment when you do your designs, right? All right, great question. One thing that I wanted to ask is, in your experience, what is usually overlooked or underestimated during the proposal process or early in the mission formulation? Like, I know in my experience, software has been one that always kind of bites you later, but in your experience, anything else that gets underestimated or overlooked early in the mission?
I would say it's the estimating of any of like new technologies. I think we're typically fairly optimistic about what that's going to cost and how long that's going to take. But it's bit us many times, and it will continue to do it for the rest of our lives probably. But that's definitely one thing. Any new technology is going to take you probably double what you initially thought it was going to take.
Yeah. Sean, how about you?
Yeah, just to piggyback of what John mentioned, I noticed that as you get new technology, you might need new ground assets to communicate with them. For example, radios, as we change out to different frequencies and or different vendors, whatever the case may be, you realize that maybe using UHF was good for mission A, and now you want to go to S-band, and that in itself can be a oversight as to what type of support you need to communicate with your satellite. And if you're not careful, you can get several months down the road and actually not have a way of communicating and circle back and go, oh yeah, we need to talk to some other folks to figure this out very quickly.
Yeah, good. Yep. And also in my experience, operations is another one that it's a little bit overlooked too. We think we can probably operate it very cheaply, but once we start looking into the interface work and everything else, the
Have 2 years, 2 years. Usually, that's the development cycle for CubeSat. And 6 months or 5 months are usually spent in testing, INT, getting it together, and have very little time to design the system. And if you pick a heritage or an architecture that you believe is right, but then you have to do all the work to prove that is right, you need experts to do that work. And sometimes there is a mix of junior versus experienced people doing the work. So, and then you have to learn, you have to come up with processes that are ideal to maximize the success rate and lower the failure rate, lower the risk. So that is always a challenge, a balance between experience, the time that you have to design, the time that you have to prove, increasing the reliability. So there is a lot of work within a 12 to 16 month period that you have to do.
All right. So we have a few questions here from Mark. He said that he heard that someone talking today about satellites as a service. I think this is similar to hosted payloads. And do you think that we're headed towards that model, or what do you think about that model? So companies have their own satellite and they're hosting payloads and instrument on their satellites, but we don't have much control of what happens on that side. Mark, if your question was geared towards something different, feel free to step in, but I think that's what you wanted to ask. So what do you guys think about that?
Yeah, but I was thinking, is Goddard thinking about it that way, in that they will try to create some service buses, and then just host instruments from whoever else at Goddard or wherever, that type of thing.
Yeah, that's a good question. We haven't thought about that much. I wouldn't think.
Yeah, I can speak that from the headquarters perspective. They are interested in that. I mean, we do that with the sounding rocket program already. And for the 71.8 missions, this is definitely something being discussed to offer a platform, and maybe a commercial platform, so we can alleviate that from the scientists having to deal with the bus side, and they just deliver their instruments with that interface. So that is being discussed, and it is something that we're considering.
All right. Thank you very much, John.
Yeah, thank you.
So we have another question from Robert, or Robbie, maybe, if I'm not mistaken. Are reliability and process requirements incorporated into your conceptual design trace space? The lack of process requirements typically float to small sat missions means that the reliability level of each mission element could be variable. For example, do we deploy one very reliable satellite or 4 less reliable satellites for the same cost and schedule? Or are we looking into, how to comply with Class D by the numbers versus the reliability of the actual satellite, and looking at that trace space?
Right, and I think this is something that I started not long ago, reliability assessment and requirements and all the processes that go behind to increase success rates for CubeSats. It's been a challenge to manage the two, because in one side is, high risk. The CubeSat missions have high risk and it's acceptable, but we want to maximize success. We want to lower any type of failure rate on CubeSats. So we have started to put in place, or we had added all the processes to lower any risk, to manage the risk for CubeSats properly. So when you look at 1 versus 4, all the front work that you do on one shows it starts to mark the reliability for the other. So I won't see the 4 less reliable as the focus on one. This is kind of we have right now, and Luis, correct me if I'm wrong. The way we have it is we're building 2 that have kind of like a baseline architecture, where we test it, we evaluate the architecture, we analyze it, so the reliability for the following missions is higher. So I don't know if that helps and answers the question.
Yeah. Anyone else want to talk about that?
Sure. If considering what's at stake, if you're doing science, that's one way to approach it. Do you need 4 satellites for your science objective, observations, measurements, so forth? Or do you need really just 1 satellite that can do all of that? And typically, early on in the process, if you're trying to get some sort of spatial separation to observe something, we would want, n number of spacecraft, and you would then, in my experience with working with some early thoughts for distributed science missions, you would then look at how your science objective is impacted. So are you able to observe 100% of the time with all 4, or are you only able to observe 50% of the time with 3? Things like that help drive some of those decisions early on, and could help drive the discussion for reliability as you start selecting components in the early stages.
All right, good. So we have a question from Dr. Heiliger from the Educator Resource Center at Goddard. And seems like she's working with a group, and they're discussing about doing a CubeSat project. And they're from other places, and she's asking, how would you guide them going forward with this? And would any of you like to be a mentor or voice your experience? So I think I can take this one. Desiree, feel free to contact me separately, we can definitely help you with that. We have really good people working in our CubeSat community, small sat community, and we can discuss how we can be of help. So feel free to contact me offline, and we can work it out. And I'm pretty sure our panel here will be more than happy to assist too.
Hi, Desiree.
So I wanted to now ask a question the same question to each of you, and that is, can you share at least one lesson learned from participating in a mission proposal or early in the mission formulation? And since we have you, Sean, on the screen right now, let's start with you.
I was hoping I was going to be the last one, but something I learned early on. Well, one of the
Maybe
first
working
things,
with the PI or
yeah, I think
flying.
yeah, I think that's a very important thing. Developing a relationship with the PI, understanding what their true objectives are, making sure that as you're working your mission, based on what was said earlier, if something's just a feature or if something's an absolute requirement for successful science. And when you get that going, you're able to move forward with your team as a cohesive unit. And I thought that was very helpful for me because we have a very large science team for the Burst Cube mission. And being able to interface with them has alleviated a lot of my stresses of wondering, are we on the right path? Are we jeopardizing science? Are we building the right platform for them? So that's one of the lessons learned. That's a good point you brought up, Luis.
All right, good. John, you want to share one lesson learned from your mission proposal experience and your early mission definition experience?
Yeah, sure. I think the biggest thing is getting cost estimates early. Really attacking that. So you got to know whether you're in the cost box, and if you're not, you've got to figure out how to get there, or if it's even possible to get there. I've been on proposals where there's a big struggle to get in the cost box. We didn't hit the cost early enough in the process, and when you're in crunch time, it's really hard to get it back in the box. And so that's probably the thing I would suggest is really get on estimating costs, even if it's just parametric type estimates, to see where you kind of stand out of the gate.
All right, great. And Juan, a lesson learned?
Yeah, so one of the things that I mentioned earlier, so this was a Class B proposal. That's the most recent, the one that it was awarded. It is Dragonfly, the mission to Saturn's moon Titan. Is the rotorcraft we plan to fly on the surface of Titan, or in Titan. One of the challenges is the concept. The concept was put together. It looked feasible based on Mars missions that have flown. So it had a lot of heritage, but it was to a different planet. So the technology readiness level, making them appropriate for that, testing it to that environment became a challenge. Keeping things clean and etc. became such a nightmare that we ended up changing the design. So in analogy to what we do in CubeSat is we pick baseline architectures that we believe are appropriate, and then we start to build the instrument, and we try to put it in. Becomes a challenge, similar. Let me see, is it reliable? Is it acceptable? And everybody has different mentality on the risk level for CubeSats. For scientists, it's like, we don't want to fail. But for other ones, it's like, oh, it's riskier, do whatever you can. So that is the challenge that you get into proposals for CubeSats compared to other ones. It's almost analogous.
Yeah, that's right. Ben, do you want to share a lesson learned?
Yeah, I'd kind of echo a lot of what some of the folks have said already. So really establishing those relationships early on with science team, really nailing down the requirements, understanding what your baseline and threshold are, and then even kind of going further potentially and having a discussion about de-scope options for your mission, because as what John was talking about, cost can be a big challenge getting in that cost box. So understanding where you might be able to go to save yourself some cost as you're kind of iterating on and progressing through that early design and proposal kind of stage.
Great. And Will, want to share a lesson learned with us?
Yeah, all the good ones have been taken. Actually, I agree with I agree with everything that's been brought up. One thing that I learned early on, and we exhausted several mission planning lab teams, is to not overextend yourself, because there are a lot of trades you can make trying to get a mission to close, and usually you can close it from several directions. So you got to figuring out what capability is limiting your ability to meet requirements, whether it's the ability to radiate enough heat to operate the instrument, or it's the ability to downlink enough data to get your minimum data set. But find out what characteristic it is that you need to optimize and you need to work in order to meet your science objective, and then focus on that without getting distracted on other things, or the newest technology, or the newest, some of these you can find a silver bullet somewhere, a new technology or something that will solve your problem, but it's probably low TRL, so that's a good thing to put in the notes afterwards, but it's not really it's not really a solution. So finding or focusing your study on the problem without getting distracted, and keeping your solution as simple and as tight as possible. I'd say that's the trick.
Yep. Well, that's true. That's great. So I know this was particularly challenging for us at NASA, because we're used to do things a certain way, and when the CubeSat mentality started picking up, and it's harder for some people than others to let go of certain processes and practices that we have embedded in our brains. But I wanted to ask you the question: what are some ways that you, as the project manager or systems engineer for a CubeSat or a smallsat, how can you help manage those expectations for adapting your typical practices to something that accommodates a lower budget and shorter schedule mission? And I don't know, Will, do you want to, since we have you,
Okay.
you want to mention something?
Yeah, that seems to be kind of an extension of my last ramble. So the question was as far as adapting, say, and this is almost kind of a question of, okay, going from the mission design lab where you do the standard Goddard large missions, and you've got a very kind of a small list of standard parts, and then going into the Wild West of the CubeSat domain, where you've got technology changing literally by the day, and you've got new vendors coming and going, and a lot of, so you have to first of all be willing to do the research and see what's there and stay current. That's what SmallSat is incredibly valuable for. Yeah, making relationships with vendors, with other people in the field. It's a small community, but at the same time knowing the limits of what a CubeSat can do and what it can't do, and not getting wrapped up. So basically, just it's a different world, and it's a faster moving smaller community, I think, for SmallSat. So that.
Yeah. Thank you. So we have under a minute left, but I wanted to see if I can throw this question in there, and maybe John, you can tackle it quickly. What was your opinion on the reviews and review expectation for CubeSats? And if we have time, Juan, you can chime on that too.
I think
we're setting the stage for the reviews and review expectations at the beginning of the mission. So I wanted to get your opinion on that.
I think it's really in your plan. It's the great time to have a mission level review, to get everybody in the room, to kind of tell your story to a panel of your peers. And I think that's when a lot of things comes out of the woodwork you wouldn't typically get. So you've got that side of it, and then you've got the peer review side, which is really helping with the technical aspects and shoring those up. So the combination of those two are critical. You know, it depends on your mission and what you're trying to do from a risk standpoint of, you know, how many reviews you have. You know, I typically recommend, you know, PDR, CDR type standard from a baseline to start with to look at, and then kind of evaluate the best for your mission. I don't think any of them should be a gate. That's not something we've done at Goddard. But holding your team accountable to answering the feedback from the panel, I think, is critical. It's not just people are going to, if you don't do that, you're going to lose credibility in future reviews if you're not actually answering the mail on some of the things that were asked. So it's highly very important to have reviews. I've seen missions not have them in the portfolio I'm working on. It's very concerning when you see that, and they run into a lot of issues later on. So having that is definitely a success. I recommend folks integrate a review cycle into the mission.
All right. I know I have this.
Don't focus on those. Focus on the ones that are the troublemakers, or the ones that you're carrying the highest risk, and then do peer reviews. But always have a review process in place. So when you get to CDR, before you start implementing, you understand what is the risk you're carrying post or the thing you're designing with the space that you're designing.
Yeah. Thank you very much. So thank you everyone for joining us. Thank you the panel for participating. It was in my opinion, a really good discussion, very good insight. For the audience, join us tomorrow. As you saw, this time we focus on proposals and early in the mission. Tomorrow, we're going to be focusing more on the mission implementation, integration, testing, and operations. We're going to have a different panel as well. So please join us. And yeah, it's going to be at the same time. You can go to the NASA Goddard virtual exhibit, and we have a section with our schedule, and you can find other talks that we have and the links to connect to this. So thank you very much for joining us. And Rob, I don't know if you have anything else before we finalize.
No, we're good to go. Thank you all to all the participants and attendees. And with that, we will stop recording. And again, this recording will be available in the media gallery afterwards. And that is all. Thank you.